Hello, my name is VenkatSubramaniam. I'm going to talk a little bit about programming concurrency on the Java virtual machine. We've been doing multi-threaded code in Java from day one, so why suddenly be excited about this particular concept? Sure, Java did a lot of nice things. Those of us who have been programming for a while remember that the concurrency API was different on each platform. You had to learn different APIs and develop different skills to program these on multiple different platforms. Java fixed all of that, isn't it? Java gave us the ability to really program concurrency with one common API. Well, that's the good news. But the bad news is, most programmers, me included, really had not taken the time to understand the Java memory model. And without understanding the Java memory model, it's incredibly hard to get concurrency right. But unfortunately, even understanding the Java memory model doesn't really help it, because you have to know when exactly the data has to go from main memory to the working memory and back. And this is a low-level detail, and keeping track of this throughout the code, every single line of code, is incredibly difficult. I'm going to say most of concurrent code written out there is broken. We just don't know it. If you're not sure about it, read Brian Gates' book on concurrency. It's one of the scariest books I've read. It tells us in so many ways we can fail writing concurrency code and ways to fix it. But once you read the book, you realize that really getting this right is incredibly difficult. There's got to be a better way to do this. I've come to experience this so much that I actually call the JDK solution as the synchronize and suffer model. It is enormous suffering the minute you start synchronizing and managing the thread safety. And a better solution, fortunately, is out there. Some of those solutions out there are, for example, programming with actors and software transaction memory. These two are quite a different approach from one another. Actors take on the approach where it isolates mutable variables. You see, when you have shared mutable variables, it's really hard to control multiple threads accessing it. That's where you get into the synchronization mess. What actors say is, rather than trying to share this mutable variable and end up with the consequences of it, why don't we isolate the variable completely? So no two threads will ever get to this data at the same time. So you have the isolation of this variable, and anytime you want to do something with this data, mostly viewed through some higher level operations or tasks you want to perform, you send messages to these actors. These actors run in a single thread. As a result, you don't have to worry about synchronization at all. On the other hand, software transaction memory takes a completely different and opposite approach. It takes the bold step to say, let's make it mutable, let's share it, but let's make it a shared mutable variable. So it gives a transactional boundary, what I would like to call as a cone of silence, and all the code you run within the cone of silence either complete when the transaction completes, or any change they make is completely lost when the transaction couldn't complete. And what software transaction memory does is it takes something that's very non-deterministic and unpredictable and makes through a managed mutable identity a very predictable process. And of course, when multiple transactions or threads compete to collide with the same data, it resolves the conflict in a pretty effective way. The beauty of this approach is, again, you don't have to do any synchronization. So the overall overarching theme here is that synchronization is evil and we want to avoid it. And there are one of a couple of different ways to handle the lack of, or to avoid synchronization rather. So actor-based concurrency is one. And of course, you could also use software transaction memory. And a third approach, of course, is to use something like a data flow. And data flow architecture was something that was popularized back in the 80s with the data flow machines. Well, those machines kind of never took off, but the concept of data flow is pretty powerful. And data flow processors actually, or data flow algorithms, give us true asynchrony. You are able to really let these processes run whenever the data becomes available. Well, but here's the beauty though. On the Java virtual machine today, from Java, you could actually reach out to these libraries and program these things. So if you're enduring synchronize and suffer, you don't have to go through it anymore. There are some really cool solutions out there. So go ahead and check out some of the advances that's happened in how you can program concurrency on the JVM.